Okay, our last video is going to calculate the speciation of a weak acid from a known pH and a known total weak acid concentration. Again, I've called that acid speciation in my workbook sheet. All right, so let's start. The pH is 6.2. You'd go out into the lake or into a river or into the ocean, and you would calibrate your pH meter using appropriate buffers, and you'd put it into the water body that you want to study, and you measure the pH. And I measured it to be 6.2. If I know pH, I know H+. Again, 10 to the negative C2, so I'm taking the antilog, the negative antilog, to get the H+ concentration. Okay, so there's my H+, it's measured. And then my total weak acid concentration, that will be the sum of the acid and basic form, total weak acid. It's going to be measured or given to you, provided. It could be the emission of ammonia from a wastewater treatment plant. It could be the concentration of naturally occurring organic material that you measured chromatographically in a lake, but you would know this number. You would also need to know the pKa of the weak acid. So I've picked acetic acid in this simple problem, and the pKa of acetic acid is 4.75. If you know the pKa, you also know the Ka. We did that in the previous video, and it's simply the antilog, the negative antilog of the Ka. Okay, so that's done. So let's go ahead and calculate the concentrations of the weak acid and its conjugate base in a solution at pH 6.2. So the first thing we're going to do is calculate the alpha. And if you know from our theory videos, that's going to be equal to H+ divided by H+ plus Ka. And we're done. And A- is going to be equal to Ka divided by H+ plus Ka. Those two numbers should add up to 1 because they're the fraction of acid, they're the fraction of base, they're the only two components, and so those two fractions have to add up to 1, and sure enough, that looks pretty good. Okay, so there we go. If we make the pH a little bit higher, make it 7, the fraction of the acid form goes down. If we make the pH lower, the fraction of the acid form goes up. And the magnitude of the change is dependent on the pH relative to the pKa. And I'll leave it to you to play around with it, and we'll have some assignments where you will do this calculation. All right, so now that we know our alphas, getting the concentration's trivial. It's equal to the total concentration times the alpha HA. And A- is equal to the total concentration times the alpha A-. And again, that's a disgusting number of sig figs. Let's clean up our spreadsheet a little bit here. And we are good to go.